Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on October 19, 2025, about 7 days ago. The big hook is that this paper debuts SAKURA, the first benchmark for editing auditory attribute knowledge in large audio language models, focusing on abstract traits like speaker gender, emotion, spoken language, and animal sounds. The paper is titled SAKURA Towards Editing Auditory Attribute Knowledge of Large Audio Language Models. And as we'll see later, the implications for model maintenance are quite significant. Beyond reliability on edited samples, the work reveals weak generalization across acoustic variations, difficulty preserving unrelated auditory knowledge, limited portability to reasoning, and rapid forgetting under sequential edits. Also, the author shared a GitHub repo. You'll find the dataset used in SAKURA, including training and testing splits, plus scripts to download the audio. There's an initial README with a brief project description. Code and usage details are still sparse for now, with more to be added soon. Well, Figure 1 shows how the benchmark tests edits to auditory attributes and what success must look like. The figure organizes 4 dimensions that matter because edits should work on the target case, carry over to similar inputs, avoid collateral damage, and influence related facts. The top reliability strip illustrates a label change after an edit. The left panels define generality cases, while the right panels detail audio and text locality. The bottom box introduces portability, which means transferring the edit to connected knowledge. Alright, Figure 2 shows the sequential editing setup that tests how long an edit survives after later updates. The diagram defines gap as the count of editing steps between when an edit is made and when it is checked. Evaluating right after the next edit gives a gap of 0. After many updates, the benchmark caps evaluation so only the first 5 edits are scored, which keeps comparisons fair across sequences. So, Table 1 compares editing methods across reliability, generality, audio and text locality, and portability on 2 audio language models. The headline is that parameter update methods reach around 100% reliability, while in context, editing lags badly. The upper block lists results for DeSTA2.5-Audio, and the lower block reports Qwen2-Audio. Generality drops most for audio neighborhoods, which shows edits rarely carry across acoustic variations. Backbone fine-tuning generalizes better than audio connector tuning, and portability remains weak despite a few balanced cases from audio fine-tuning. So, Figure 3 compares sequential editing as the edit gap grows. Edit gap means the count of later edits between the change and the check. Reliability and generality fall steadily, which signals forgetting of prior edits. On DeSTA2.5-Audio, Mend and Knowledge Editor collapse into repetitive outputs, while IK stays relatively stable across larger gaps. On Qwen2-Audio, the in-context variants lag because the model shows weaker reasoning. Portability holds up better, with IK and audio fine-tuning leading their respective models. Alright, 2 takeaways stand out. SAKURA shows that changing targeted audio attributes is easy on the exact edit, but generalization across acoustic variations, preservation of unrelated knowledge, and portability to reasoning are weak, and sequential edits forget quickly. The broader implication is clear. We need editing methods tailored to abstract auditory representations. That is it for the AI Research Roundup. I'm Alex. Thanks for listening.